Good evening, everyone. Myself, Anjali Ravashankar Prasad. I'm a PMRF scholar at IIT ISM Dhanbad. Today, we are going to start with the week 8 assignment session of numerical methods NOC 23 MA 94, taught by Professor Amir Kumar Nayak and Professor Sanjeev Kumar from IIT Roorkee. Okay, so let's start. So, first question is, which of the following is not a predictor corrector method? So you have to determine which of the following options is not a predictor corrector method. Okay. So is it Milnes method or modified Eilers or Adams-Bashforth or Picard's method?
Picard.
Yes. So correct option is D. Picard's method is not a predictor corrector method. Okay. So next move to the next question. So question number 2 is, consider the IVP dy by dx plus 2y is equals minus cos of 4x, where y of 0 is equals to 3, that is initial value is given, and the best estimate of dy by dx at 0.4 using the Rangakutta method, second order, with step size h equals to 0.2 is. So you have to calculate the dy by dx at 0.4 using Rangakutta second order method. Okay, here step size will be 0.2. So find it. What are you getting? Is it 1.33, 1.43, 1.53 or 1.26? Use the Rangakutta second order method formula and estimate the value of dy by dx at 0.4. So did anyone get the answer? Did you get the answer? Anyone? Okay. So previous question was, which of the following is not a predictor corrector method? So correct option is D, Picard's method. Okay. Now what about the next question? Have you solved it? What are you getting? Did you get the answer? Anyone? Okay. So here you have been given dy by dx plus 2y is equals to minus cos 4x, right? So what will be y dash? Y dash will be equal to minus 2y minus cos 4x, where initial value y of 0 is given as 3, okay? And step size h is equals to 0.2. You have to calculate y dash as, y at 0.4, right? So for that, using second order Rangakuta method, uh, first what we will calculate, k1 will be given by h times f of x naught comma y naught, right? So here h is what, 0.2, then just substitute the value of x naught y naught. So here x naught is 0 and y naught is 3, right? So substitute 0 comma 3 in this function, okay? At the place of y substitute 3 and at the place of x substitute 0, okay? And see what you are getting. So you get f of 0.3. Fine. Now so f of 0.3 will be what? When you substitute it, you will get zero point 0.2 times minus 7, okay? It should be 0 comma 3. Fine. Here it should be 0 comma 3. So when you calculate f of 0 comma 3, you will get minus 7. Okay, that will be equal to minus 1.4. So in this way you will get k1, that is minus 1.4. Now once you have calculated k1, we will go to k2. How will you get k2? K2 is equals to what? H times f of x naught plus h comma y naught plus k1. The k1 that you have got in the previous step. Okay. So just substitute those values here. Again x naught and y naught will be 0 comma 3. And h is what? The step set that is 0.2. So substitute at the place of h, substitute 0.2, at the place of x naught substitute 0, and at the place of y naught substitute 3. And here k1 is what? Minus 1.4 that we have calculated. So when you will put here x naught plus h and y naught plus k1, you will get f of 0.2 comma 1.6. Okay, just check it. Are you getting? Are you getting till k2? And once you will find f of 0.2 comma 1.6, substitute here at the place of x 0.2 and at the place of y substitute 1.6. So you'll get minus 0.78. See, are you getting the values of k1 and k2? Okay. Now once you have got k1 and k2, now we can find out y1, right? So y1 is what? According to Rangakutta second order method, y1 will be is equals to y0 plus k1 plus k2 upon 2. Okay. Here y0 is what? 3, and you have just calculated k1 and k2. Substitute here and divided by 2. So you get 3 minus 1.09. Okay. So when you will subtract it, 3 minus 1.09, you will get 1.9. Fine. Therefore, y of 0.2 is 1.91. See, are you getting y of 0.2 as 1.91? So once you have got y of 0.2 as 1.91, now we can proceed to the next step. That is, we have to calculate y of 0.4. Okay, for the next iteration. So again taking x1 comma y1. Now here at the first iteration we have took here x0 and y0. Now we will take x1 comma y1 in place of x0 comma y1 y0 and repeat the process. Okay. So here again k1 will be what? H times f of x1 comma y1. Okay. So h is again 0.2 and f of x1 y1. So here x1 is now 0.2 and y1 is 1.91. Okay. So at the place of x here substitute 0.2 and at the place of y substitute 1.91. So you will get the value of f of x1 comma y1. Okay. And find it. See, are you getting it as minus 0.9? If you are getting K1, then you can proceed to K2. K2 will be what? H times f of x1 plus h, comma, y1 plus k1. Okay. So again x1 and y1, you know x1 is 0.2 and y1 is 1.91. So substitute those values and take h as 0.2. You will get k2 as minus 0.4. Okay. Now once you have got k1 and k2, you can find out now y2. So y2 will be, by the Rangakutta second order method, y2 is what? y1 plus k1 plus k2 divided by 2. Okay. So here it is k1 minus 0.9 and k2 is minus 0.4 and y1 is 1.91. So substitute those values, you will get 1.26. Fine. Therefore, y of 0.4 is 1.26. Okay. And the correct option is D. Just check your calculations. If you have doubt in any of the steps, tell me. So is it clear to everyone? Question number 2. Have we got the best estimate as 1.26? Is everyone getting 1.26? Or if you have any doubt, let me know. So shall we move to the next question? I hope it is clear to everyone. So we are moving to the next question. Okay. So question number 3 is, consider the initial value problem. Dy by dx is equals to minus 2y plus x plus 4. Okay. So this is the IVP where y of 0 is 1. So the best estimate of dy by dx at 0.2 using Euler's modified method with step size h is equal to 0.2 is. So you have to calculate the best estimate of dy by dx at 0.2 and this is your IVP using Euler's modified method. Okay, here the step size will be h is equal to 0.2. So find it, either it is 1.24, 1.38 or 1.34 or 1.48. Find it. So did anyone get the answer? Okay, just check your calculations. The correct option will be C. So here f of x comma y is minus 2y plus x plus 4. Okay, this term. Now the modified Euler method is ym plus 1 is equals ym plus h times f of xm plus, this ym plus 1 is here in the subscript. Okay, so ym plus 1 is equals ym plus h times f of xm plus half h comma ym plus half of f of h times f of xm comma ym. Okay, so we have to calculate at 0.2. Okay, and step size is 0.2. So we have been given x naught and y naught, we have to calculate y1. Okay, so x naught is what, 0, and y naught is, corresponding y naught is 1. Okay, so finding out f of 0 comma 1. So when you substitute here x as 0 and y as 1, you will get 2. Okay, so f of x naught comma y naught is 2. So y1 will become, by substituting here, just substitute at the place of m, put 0. Okay, so here 0 plus 1, you will get y1. So y1 is equals to y naught plus h times f of, here x naught plus half into h comma y naught plus half into h times f of x naught comma y naught. Okay, so here it will be equals to y naught. What is here y naught? 1, right? So 1 plus h is 0.2 times x naught is 0. So 0 plus half into h, half into h, that is 0.2, comma, what is y naught? Y naught is 1 plus half into h, that is 0.2 of f of x naught comma y naught, that is 2. So substitute here. Okay, then whatever value you will get here, comma, something you will get value of y. Okay, so substitute those values of x and y in this equation. So you'll get here 1.7. Okay. So you'll get 1 plus zero point 0.2 times 1.7. Fine. So y1 will be 1 plus zero point 0.2 into 1.7. So this will give you 1.34. Right. So therefore this is y1, that is at first step size, that is 0.2. So y of 0.2 will be 1.34. Okay. So correct option is 3. C. Just check your calculations and the formula. You just have to substitute the values in the formula and you'll get the answer. If you have any doubt, tell me. If you have doubt in any of the steps, tell me. Just substitute all the given values and apply the formula using step size as 0.2. So do you have any doubt? Shall we move to the next question? Is it clear to everyone? So the next question is question number 4, that is you have to find the order and degree for the ordinary differential equation. You have been given the ordinary differential equation and you have to find out its order and degree. So the equation is x is equals to 1 plus dy by dx square minus half into dy by dx whole to the power 4 plus 1 by 3 into dy by dx whole to the power 6. So this is easy one. I guess everyone should get it. So find out what is the order and degree of this differential equation.
Order 1 degree 6.
Okay. So it's, I think everyone has got it. Okay. So the correct option is A, that is order is 1 and degree is 6. Here you can see. Okay. Now next question is question number 5, that is for the IVP y dash is equals to x minus y square. You have been given this initial value problem where y of 0 is equal to minus 1. Okay. The value of y of 1 using Picard's method after two approximations is. So you have to use two approximations and find the value of y of 1. Fine. And this is your IVP. So use Picard's method and get the solution at y of 1. So find it, is it 1.583 or 1.683 or 1.783 or 1.883? Keep in mind that you have to use two approximations to reach till y of 1. Okay. So since it is 0, so this will be the, so first approximation will be at 0.5 and the next approximation will be at 2, sorry 1. Okay. So consider it in that way. N0 takes 0 and the next iteration N1 will be 0.5 and N2 will be 1. So anyone did get the answer? Anyone get it? What is the answer you're getting? Use Picard's method and find out it with two approximations. So the answer will be first here y dash is given as x minus y square, right? And y of 0 is equal to minus 1. You have to calculate y of 1, right? So what is the Picard's method? The formula is given as yn plus 1 is equals y naught plus integration over x naught to x f of x comma yn dx, where n will be 0, 1, 2 and all. Okay. So here n equal to 0, that is the at y naught, that is the starting point. Okay, that is the initial value. Then when you will substitute n equals to 1, you will get the next approximation. And when you will substitute n equals to 2, you will get the next approximation. Okay, so you have to go till n equals to 2. So n1 as at n is equals to 1, that is y1. First you have to calculate y1 using the given y0, then you have to calculate y y2. Okay, so y1 that is at 0.5. Here it was 0, so next approximation will be at 0.5, right? So this will be equals to, what is y0? Y0 is minus 1. So substitute here minus 1 plus integral over x naught is 0. So 0 to x, then f of x comma y naught. Y naught is minus 1. So f of x comma minus 1 dx. So in this, here x minus y square is f of x comma y. So when you substitute at the place of x, it will be x only, and at the place of y, you have to substitute minus 1. Okay. So you'll get it as minus 1 plus integral over 0 to x, and here x minus 1. Okay, 1 minus 1 square, it will give you 1. So integral over 0 to x, x minus 1 dx. Okay, so this will be equal to minus 1 plus, so integrate it, you'll get x square by 2 minus, its once integration will be x, and find the limits from 0 to x. So you'll get minus 1 plus x square by 2 minus x. So y1 at 0.5 is given by this value, minus 1 plus x square by 2 minus x. Okay. See, are you getting y1 of 0.5 as this? Are you all getting y1 of 0.5 as minus 1 plus x square by 2 minus x? Now once you have got this, you have to calculate y2. Okay, so y2 will be at 1. Okay, that is the next approximation. So y2 at 1, that will be given by minus 1. Again y0 is minus 1 plus 0 to x. Again here x0 is 0 of f of x comma. Now here you have to substitute the value of yn. So when we are at y2, so yn will be y1. And what is the value of y1? Minus 1 plus x square by 2 minus x. Okay, so substitute it over here. Then dx. So you will get minus 1 minus, just substitute, put here at the place of y, substitute these value and find its square, and you'll get x minus y square, and then integrate it from 0 to x. See, are you getting it as minus 1 minus x square by 2 plus x cube by 3 plus x power 4 by 2 minus x power 5 by 20. Just check it. Okay, so once you have got this y2, I hope everyone is getting it. So at the place of x, substitute 1. Okay, here. So you will get minus 1 minus 1 minus here 1 square by 2 plus 1 by 3 plus 1 by 2 minus 1 by 20, and solve it, you will get 1.583. Okay, so sorry, here it will be y2. So y2 at 1 is given by 1.583. Okay, so correct option is A, 1.583. So are you all getting it? Do you have any doubt in any of the steps? If so, then tell me. Is it clear to everyone, all the steps? If you have any doubt, tell me. Okay, so let's move to the next question. So question number 6 is, given IVP, y dash plus y is equals to sin x, comma y of 0 is equal to 1. Okay, so initial value That is y0 is given as 1. And using a step size of h is equal to 0.2. You have to use the step size. So the value of y of 0.4 using Euler's method is, so for the given IVP, you have to calculate y of 0.4 with the step size h is equal to 0.2 using Euler's method. Okay. Find it. Is it 0.6397 or 0.6797 or 0.6717 or 0.6597? Use the Euler's method and take the step size at 0.2 and calculate y of 0.2. Here f of x comma y will be sin x minus y. Okay. So what are you getting? The answer? Anyone got the answer? See? Okay. So just check your calculations. The correct option is B, 0.6797. Okay. It will be minor difference in the calculation. So just check it. You should get 0.6797. Okay. So here y dash plus y is equals to sin x. Fine. And y of 0 is 1 and step size h is equal to 0.2. Fine. So from here you will get y dash is equal to sin x minus y. This is what f of x comma y. So by Euler's method, what is the Euler's method? Yn is equal to yn minus 1 plus h times f of xn comma yn. Okay. So for the first iteration, since h is 0.2, so you will have to do two iterations, right? For first iteration, you will reach till y of 0.2 and in the next iteration, you will reach till y of 0.4. So for the first iteration, here it will be y1. Just substitute at the place of n as 1. Okay, so here you will get y1 is equal to, here you will get y naught plus h into f of x naught comma, here it will be comma y naught. Okay, so x naught is 0 and y naught is 1. Substitute here sine 0 minus 1. Okay, so you'll get it as minus 1, right? So here y naught is 1 plus 0.2, that is the step size, into minus 1. So y of 0.2 will be 0.8. Okay. See, are you getting y of 0.2 as 0.8? Just tell me, are you getting y of 0.2 as 0.8? So I hope you are getting y of 0.2 as 0.8. Now we have to calculate y of 0.4. That is the next iteration. So here at the place of y1 it will be y2 is equal to, here it will be y1. So y1 what you have got, 0.8. 0.8 plus h, that is 0.2, into f of x1 comma y1. So x1 is 0.2 and y1 is 0.8. So substitute here. So you will get sine of 0.2 minus 0.8. Okay, just check that your calculator should be giving values in radians and not in degree. Okay, if it is in degree, then the answer will differ. So you will get the answer as 0.6797. Solve it. See, are you getting y of 0.4 as 0.6797? Okay, as the correct option is B. Okay, I hope it's clear to everyone. Okay, so let's move to the next question. So question number 7 is, which of the following methods agree with Taylor series solution up to term in h4, h power 4? Okay, so which of these methods agree with the Taylor series solution up to the term h power 4? Okay, so is it modified Euler's method or fourth order Runge-Kutta method or Picard's method or Milne's method? Which of this method agree with Taylor series solution up to term h power 4?
Fourth order Ranga.
Okay. So the answer is B, that is fourth order Runge-Kutta method. Okay. So this you will get from the formulas and the definition. Let's move to the next question. So question number 8 is, the smallest interval on which there exists unique solution of the IVP y dash is equals to e power y, comma y of 0 is equal to 0. Okay, so you have to find the smallest interval on which there exists unique solution of this given IVP, that is y dash equals to e power y, comma y of 0 is equal to 0. Okay, so find out the smallest interval, find it. Is it mod x less than equal to 1 upon 2e, or mod x less than equal to 2e, or mod x less than equal to 2 upon e, or mod x less than equals to 1 by e? Find it. Which is the smallest interval such that there exists unique solution of the given IVP.
Cross-selling.
So repeating A, check it nicely. The correct option is D, mod x less than equal to 1 by e. How will you get it? So here dy by dx is equals to e power y. Okay, so using the existence and uniqueness theorems, so here f of x comma y is e power y, and we can let that mod, we will find the bound of upper bound of f of x comma y, that is e power y. So modulus of e power y will be less than equal to, since y is, let x be bounded by mod x less than equal to a, and let y be bounded by b. Okay, so mod x is less than equal to a and mod y is less than equal to b. So here mod of e power y will be less than equals to e power b. Okay, so this will be the bound, upper bound of this function f of x comma y, that is e power y. Okay, let it be m. Here it should be capital M. Okay, now for finding the interval, we need the h value. So h is given by minimum of a comma b by m, right? So what is a? That is mod x less than equal to a. That a, that is here, comma b by m. Okay, now we have just calculated the value of m, that is the upper bound, that is e power b. So substitute here, so you'll get minimum of a comma b by e power b. Okay, now we have to find the minimum of both of this. So let's find at which value of b we will get the maximum value of b or the optimum value. Okay, so let consider this as the function of b. So let phi of b is equals to b by e power b. I hope it's clear till h is equal to minimum of a comma b by e power b. Till this step, is it clear to everyone? Is it clear? So once you have got this, h is equal to minimum of a comma b by e power b. So let b by e power b as the function of b. We have to find its optimum. So we will find its derivative. Okay, the phi dash of b will be, just find derivative of this b by e power b. So it will be b into derivative of, oh, sorry, e power b minus e power b, derivative of b. Okay, so upon e to the power 2b. Okay, equals to 0. Fine. Now when you'll take e power b common, so you'll get b minus 1 by e power b is equal to 0. Okay, by solving this you will get b is equal to 1. So at the value of 1, b is equal to 1, you will get this, get the optimum solution of this b by e power b. Okay, so that is 1 upon e. Okay, when you'll substitute here at the place of b, when you'll substitute 1, you will get 1 upon e. So which is minimum out of a and 1 upon e? So for that you just equate a is equal to 1 by e. So again you are getting 1 by e. Okay, so in anyhow the minimum will be 1 by e. Okay, so h is 1 by e. Fine. So once you have got h, so by the existence and uniqueness theorems, you will get modulus of x minus 0 less than equal to 1 by e, that is h. Okay. So hence correct option is D. The smallest interval on which there exists the unique solution of the IVP is modulus of x less than equal to 1 by e. Okay. Is it clear to everyone? Is there any doubt?
Can you explain?
Okay, I'll explain it once again. So here you have to find the smallest interval on which there exists the unique solution of the IVP. Y dash is equals to e power y comma y0, y of 0 is equal to 0. Okay, so x naught is 0 and y naught is again 0. Okay, so the intervals, that is the rectangle on which you have to find the smallest interval, that is modulus of x minus a x naught, that is 0. So modulus of x less than equal to a, and modulus of y less than equal to b. Okay, so on this rectangle you have to calculate the smallest interval. So for calculating the smallest interval, you need to calculate first the value of h. Okay, so for calculating the value of h, you need minimum of a comma b by m. Here a and b are the bounds of the rectangle, that is mod x less than equal to a and mod y less than equal to b. So those values you have to write it over here, a and b. And what is m? M is the upper bound of the function f of x comma y. So here f of x comma y is e power y. Okay, now you have to calculate its upper bound. So e power y is bounded by, since y is bounded by what? B. So modulus of e power y is bounded by e power b. Okay, so you have got m as e power b. So substitute at the place of m, just substitute e power b. So here you will get h is equal to minimum of a comma b by m as minimum of a comma b by e to the power b. Okay, now you have to calculate the minimum of these values, but you don't know about a and b. So for that we will calculate the extreme value of b by e power b. For that, consider, since it is a function of b, let phi of b is equal to b by e to the power b. Okay, so find the derivative of this and equate it to 0. So when you will find the find it using u by v rule, so you will get b into e power b minus e to the power b upon e to the power b whole square. Okay, now simplify it. So by taking e power b common from the numerator and cancelling out it, you will get b minus 1 by e power b is equal to 0. So this will give you b is equal to 1. Okay, now substitute here, that is at the value of b is equal to 1, the this function will have its extreme value. Okay, so substitute here 1, so you'll get 1 upon e, right? Now what about a? How will you get that which one is minimum? So for that, finding it, you will just equate a equal to whatever you have got, a equal to this function value. So when you equate it, you will anyhow get again as 1 upon e. Okay, so now h is what? 1 upon e. Fine. So the smallest interval is given by modulus of x minus x naught less than equal to h, and here h is 1 by e. So the correct option is D. The smallest interval on which there exists unique solution of the IVP is mod x less than equal to 1 by e. Is it clear now?
Yes, ma'am. Thank you, ma'am.
Okay. So shall we move to the next question? Just check everyone. Is it clear to everyone? Or anyone else, if you have doubt, tell me. I'll explain it again. So is it clear? Shall we move to the next question?
Yes, ma'am. Yes, ma'am.
So question number 9 is the IVP y dash is equals to 2 into y to the power half, comma y of 0 equal to 0 has. So find out, does it has no solution or unique solution or two solution or infinitely many solutions. Find out, are you getting no solution, unique solution, two solutions or infinitely many solutions? will be the correct option. So this has infinitely many solutions. Okay. Since here you have solved many questions like this, where if here alpha, that is y power, this term lies between 0 to 1, then it will have infinitely many solutions. Okay. So let's move to the next question. Question number 10 is, given IVP y dash is equals xy minus y square, where y of 0 is equal to 1, and using a step size of h is equal to 0.3, the value of y of 0.3 using the fourth order Rangakuta method is most nearly to what? Okay, so you have been given the IVP. Here f of x comma y is xy minus y square, and using the step size h is equal to 0.3, you have to calculate the value of y of 0.3 using fourth order Rangakuta method. Okay, so use the fourth order Rangakuta method having step size h is equal to 0.3 and calculate this. See what you are getting. Is it 0.8117 or 0.8017 or 0.8077 or 0.8177? Find it. Use the fourth order Rangakuta method and find the solution. Since step size is h is equal to 0.3, so you have to take only one iteration. Okay. We're getting it as A. Others, have you got it as A? Just check your calculations. The correct option is B, that is 0.8017. Okay. So here we are using Rangakuta fourth order method.
Here 0.3 is asked, ma'am. Suppose if dy by dx of y 0.3 is asked, how to proceed, ma'am?
Same you have to proceed. Dy by dx at 0.3 means, yeah, they are asking you the best estimate, right?
Ma'am?
You have to proceed similar as we have done in the previous questions, like second or third question, it was like that only. Okay, I'll just make the quick review of that, okay, after this question.
Oh,
So here y dash is equal to xy minus y square. So f of x comma y will be xy minus y square. Fine. Now x naught is what? 0 and y naught is 1. Okay. And h is equal to 0.3. That is the step size. We have been asked to find y of 0.3. Okay. That is, you have to do only one iteration. You have to calculate y1. That is 0.3. At 0.3. So for the by Rangakuta method, you first need k1. So what is k1? K1 is equals to h times f of x naught comma y naught. So here x naught is 0 and y naught is 1. And this is our f of x comma y, that is xy minus y square. So at the place of x naught substitute 0 and at the place of y naught substitute 1. What you'll get? Minus 1. And here h is 0.3. So you'll get minus 0.3. So k1 is minus 0.3. Okay. Now we will proceed to K2. So K2 is what? H into f of x naught plus h by 2 comma y naught plus k1 by 2. Okay. Here x naught and y naught will be again 0 comma 1 and h will be again 0.3. But what is k1? That is minus 0.3. Okay. So update those values and you'll get the f of some term of x and comma some term of y and substitute that here xy minus y square at the place of xy minus y square and take h as 0.3. So see, are you getting k2 as minus 0.1785?
yes, ma'am.
Okay. Now calculate k3, that will be h times f of x naught plus h by 2 comma y naught plus k2 by 2. All the values will be same. Just you have to replace k2 as in the place of k1 you'll get minus 0.1785 here. So update those values and you'll get K3 as minus 0.2079. Okay, once you have got K3, now you'll proceed for K4. So K4 is h into f of x naught plus h comma y naught plus K3. Okay, here K3 will be minus 0.2079. So substitute all those values and you will get K4 as minus 0.117. Okay, now once you have got K1, K2, K3 and K4, substitute all those values here in the fourth order Rangakuta method. That is y1 at 0.3 is given by y0 plus 1 by 6 times k1 plus 2 k2 plus 2 k3 plus k4. Okay. So substituting these values from here k1, k2, k3 and k4 and y0 is 1. So put all the values, you will get y of 0.3 as 0.8017. Okay. So correct option is B. Check, is it everyone getting? The correct option is B.
Yes, ma'am.
Okay. So this was the last question. I'll just make the quick review for all the questions that we have discussed today. Okay. So those who have joined later, they will also get the gist. Okay. So the first question was, which of the following is not a predictor corrector method? So you have to determine which of these following methods is not predictor corrector method, that is Milner's method or modified Eilert's method or Adams-Bashforth or Picard's method. Okay. So correct option is Picard's method. Right. Next question number 2 was, consider the IVP dy by dx plus 2y is equals minus cos of 4x where y of 0 is 3. Okay, so you will be asked the question like the best estimate of dy by dx at 0.4 using the Rangakutta second order method with step size h is equal to 0.2 is. So here you have been asked the best estimate of dy by dx at 0.4 means you have asked the value of y at 0.4. Okay, they mean the same. Okay.
Yes, ma'am. Yes, ma'am.
Okay. So here again you have to follow the same procedure. Y dash is equal to minus 2y minus cos 4x, where y0 is 3 and h is 0.2 and y of 0.4 you have to calculate. Okay, so using the second order Rangakuta method, since we have started with 0 and we have to take step size as 0.2 and we have to reach till 0.4. So we need two iterations. Okay, so for first iteration we have taken k1 and k2. So here you can just substitute in the values uh, and you'll get k1 as minus 1.4 and k2 as minus 0.78. Okay, so y1 will be what? Y0 plus k1 plus k2 divided by 2. Here y0 is 3. So substituting these values, you'll get y1 as 1.9. Do you have any doubt?
No, ma'am.
Okay. Then y of 0.2 is 1.91. Similarly, you can calculate the next iteration y2, that will give you y of 0.4. That is the best estimate of dy by dx at 0.4. Okay. So taking x1 comma y1 in place of x0 comma y0 and find out k1 k2. Similarly, find out y2, that will be y1 plus k1 plus k2 by 2. This will give you 1.26. Okay. Clear now?
Yes, ma'am. Yes, ma'am.
Okay. Similarly, question number 3 was consider the IVP. This dy by dx is equal to minus 2y plus x plus 4 comma y of 0 equal to 1, and the best estimate of dy by dx at 0.2 using Euler's modified method with step size h is equal to 0.2 is. So you have to use Euler's modified method and take step size as 0.2 and find this best estimate of this IVP at 0.2. Okay, so we have just substituted the values in the modified Euler method. Here it will be ym plus 1 in the subscript is equal to ym plus h into this formula, and here f of x naught comma y naught, since x naught is 0 and y naught is 1, so you'll get it as 2. Okay, so substitute those values and you'll get y of 0.2 as 1.34. Okay, now the next question was the order and degree for the ordinary differential equation x is equals to 1 plus dy by dx whole square minus 1 by 2 dy by dx whole to the power 4 plus 1 by 3 dy by dx whole to the power 6. So what is the order here? 1 and the degree is 6. Okay, so correct option is A. Fine. Now the next question was for the IVP y dash is equal to x minus y square comma y of 0 is equal to minus 1. This is the IVP. The value of y of 1 using Picard's method after two approximations is. So you have to calculate the value of y of 1 using Picard's method but after two approximations. So from 0 to 1 you have to calculate two approximations. So in n will be n naught will be 0 and n1 next iteration will be at 1, n is equal to 1, and next iteration will be at n equals to 2, that is at y1 0.5 and y2 at 1. Okay, in this way you will get the two approximations and you will reach till 1. Here it will be y2. Fine. So by Picard's method, yn plus 1 is equal to y naught plus integration over x naught to x f of x comma y and dx, where n is equal to 0, 1, 2. Fine. So y dash is what? X minus y square. So this is your function f of x comma y. Fine. Now y of 0 is what? Minus 1 here. So you have to calculate the value of y of 1. So first we have calculated y1 at 0.5. So this will give you minus 1 plus x naught is 0, so 0 to x f of x comma y naught, that is minus 1. So substitute the value of this f of x comma minus 1 in this at this place, x minus y square, and you will get x minus 1. Integrate it, you will get this. Okay, so in this way you will get y1. Now your main step is to find y2 at 1, that is minus 1. Again your y naught will be minus 1 plus 0 to x f of x comma y. Okay, y1, right? Here it will be y1. So y1 is this that you have calculated. Substitute it over here and put this in this at the place of y. Okay, and integrate it. You will get this value. Okay. Now once you have got this, you have to calculate y2 at 1. So at the place of x, substitute 1 and solve it. You will get y2 of 1 as 1.583. Okay. So correct option is A. Fine. Now the next question is, given IVP y dash plus y is equal to sin x, y of 0 equal to 1, and using a step size h is equal to 0.2, the value of y of 0.4 using Euler's method is, so you have to use the Euler's method and take the step size as h is equal to 0.2 and you have to calculate the value of y of 0.4. Okay, so it's easy again. Y dash is equals to, you have to take the function that is sin x minus y. Here y of 0 is equal to 1, that is x naught is 0 and y naught is 1, and h, that is the step size, is given by 0.2. Okay, so you'll get y dash is equal to sin x minus y. Fine. So by Euler's method, what is the Euler's method? Yn is equals to yn minus 1 plus h into f of xn comma yn. Fine. Now at the place of n, what you'll write? You have to calculate the first iteration. So take yn, n as 1. So y1 is equals to, here you will get n minus 1, that is 0. So y naught plus h into f of x naught comma y naught. So x naught y naught, just substitute all the values. You will get y at 0.2. That is 0.8. Now you have to reach till y of 0.4. That is, you need to calculate y2 also. So y2 will be equal to y1 plus 0.2 into f of x1 comma y1. So substitute all the values, you will get y of 0.4 as 0.6797. Okay, so correct option is B. Fine. Now the next question was, which of the following methods agree with Taylor series solution up to term in h power 4? Okay, so which of this agree with the Taylor series solution up to term h power 4? That is fourth order Rangaputta method. Okay. Now the next question was, the smallest interval on which there exists unique solution of the IVP y dash is equals to e power y of 0 equal to 0, which is the smallest interval. So for that we have to dy by dx is equal to e power y. This is the function f of x comma y. We have to calculate its upper bound. So we know the rectangle is mod x less than equal to a and mod y less than equal to b. We have to calculate the smallest interval on this rectangle or on this domain. So mod e power y will be bounded by e power b. That is, take it as upper bound, that is m. So h is equals to what? Minimum of a comma b by m, by the existence and uniqueness theorem. Now m is e power b. We have found it here. So substitute here. Now we don't know the bounds like extreme values, so that we can choose which is minimum. For that we will find the extreme value of this. Okay, so take this as function of b. This is b by e power b. Okay, now we will find the extreme value. For that we need to derivate it with respect to b and equate it to 0. So when you will do it, you will get b minus 1 by e power b is equal to 0. This will give you b is equal to 1. Fine. Therefore you'll substitute here 1. So you'll get 1 upon e. Now which is minimum among a and 1 upon e? For that we will equate a is equal to whatever value you have got here. So it is again 1 upon e. So the minimum will be 1 upon e. Okay. So h is 1 upon e. So x minus 0. So the bound will be the smallest interval on which the unique solution exists. That will be modulus of x minus 0 less than equal to 1 by e. Fine. So option D is correct. Okay. Now question number 9 was, the IVP y dash is equals to 2y power half comma y0 is equal to 0 has Does this has no solution, unique solution, two solution, or infinitely many solutions? So the answer was it has infinitely many solutions. Okay. Now moving to the next question, that is the last question. Given IVP, y dash is equal to xy minus y square, y of 0 equals to 1, and using a step size of h is equal to 0.3, the value of y of 0.3 using the fourth order Rangakuta method is most nearly. So you have to use the Rangakuta method, fourth order, and you have to estimate the value at y of 0.3. Okay. Now, since the step size is 0.3, so we have to calculate till only one iteration. So this is your f of x comma y, and x naught is 0 and y naught is 1 and h is 0.3. So substitute the values in k1, k2, k3 and k4. You will get these values and you will get y1 at 0.3 the by the formula y naught plus 1 by 6 times k1 plus 2k2 plus 2k3 plus k4. Substitute all the values, you will get 0.8017. Okay, so hence the correct option is B. So these were all the 10 questions that we discussed today. I hope it is clear to everyone.
Yes, ma'am. Thank you so much.
Okay, so if any doubt in any of the questions, then you can ask.
No doubts, ma'am.
So thank you for joining and
Thank you.
thank you for being in all these sessions. Thank you. So here we will end the session. Okay.